Okay, welcome to an introduction to the binomial expansion. Let's get into it. Now, binomial, bi means two, and you can see here you've got the addition of two thing, and expansion means we're raising it to a power. Now, what you've got on the screen here is you've got a plus b squared. You've seen this before quite a lot, okay? Now, I'm going to go through this. You'll see why in a second. But a plus b squared just means you're multiplying the two brackets, a plus b, and you're timesing it by itself. If you square something, you multiply it by itself. So a plus b times a plus b. Now we can work through this using your method. You might use a table. I use the FOIL method. So I do the first with the first times the second with first, and second with second. You're going to see why this is. It's all going to play out in a second. Now if we work through this, we can go and do a times a, which gives you a squared. A times by b, which gives you plus ab. We've then got b times a, which is ba, which is the same thing as ab, because multiplication is commutative, so plus ab again. And then we've got b times by b, which gives you b squared. Okay, now we can simplify here. When you expand brackets, you can typically simplify it. So this is going to simply go to, well, the a squared stays as it is, and you've got ab happening twice. You've got 1ab plus 1ab, which gives you 2ab. So a squared plus 2ab plus the b squared on the end. So you've expanded the bracket a plus b raised to the power of 2. Okay. What about the one down below? You've got a plus b cubed. Now this is similar to the previous one, but this time you're now timesing a plus b by itself, not once, not twice, but 3 times. Okay. Now you've just seen previously that a plus b times by a plus b gives you this over here. So I can rewrite this simply as just a squared plus 2ab plus b squared. I'm going to keep it in a bracket, and we're timesing this through by this over here, which is a plus b. Okay? And again, like before we work through our method, you could be using a table method. I like to use the FOIL method. And we just work through this, being careful with timesing our terms out. So I go and do a squared with a squared with b. Okay, I'll work through it one at a time. So a squared times by a gives me a cubed. A squared times by b gives me plus a squared b. I then go and do 2ab times a and 2ab times by b. So 2ab times by a is going to give me plus 2a squared b. And then 2ab times by b is going to give me 2ab squared. So plus 2ab squared. I've then got b squared times a and b squared times by b. B squared times by a is b squared a, or ab squared. The order, again, doesn't matter. So plus ab squared. I've got b squared times by b, which is b cubed. So plus b cubed. Now, there will be some like terms here, so let's go and simplify it a little bit if we can. I've got a squared b, which is here, 1a squared b plus 2a squared b. They're like terms because they've both got a squared b in them. And I've also got down here, let's go and do it in blue, I've got plus 2ab squared and plus 1ab squared. Okay, so now just kind of tidying everything up here, we can write this as follows. This is going to be equal to a cubed 1ab squared plus 1a squared b plus 2a squared b gives me plus 3a squared b. I've then got plus 2ab squared plus ab squared, which is plus 3ab squared plus b cubed on the end. And this is the answer to a plus b all cubed. Okay, now maybe you just sat through that and you've been thinking, okay, that seemed a little bit painful and time consuming. Well, the question really arises, we've just seen the expansion of those two there, those two binomials, to the power of 2 and to the power of 3. What about if you want to raise these to larger powers, such as 4, 5, 6, or anything? And if you continue to work through it by hand, like we've just been doing, you're going to be there for a long time and you could make mistakes. So for example, if I wanted to look at a plus b to the power of 4 and expand it, we need a better method to do this, which you're going to see in a second. But for the time being, I'm just going to tell you that if you did expand this, you would get this down below. Now, we can draw some really important facts from these expansions here. Really important facts. If we look at the coefficients before each of the terms, what I mean by that is the numbers before each of the terms. Okay, let's look at it on the first one, a plus b squared. Well, before the a squared, you can't see it, there is a 1. It's 1a squared. You've then got plus 2ab plus 1b squared. I'm going to write these coefficients, these numbers before the terms, over here. 1, 2, 1. For a plus b cubed, again I've got a cubed, which means 1a cubed plus 3ab squared, a squared b, sorry, plus 3ab squared plus 1b cubed. Let's write these coefficients below the previous ones. And then finally, for a plus b to the power of 4, we've got 1a to the 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus 1b to the 4. And again, let's write these coefficients over here. Now, what you can see here is the beginning of something very, very important in mathematics called Pascal's triangle, which you'll see fully in a second. Now, the way this works is, and it's really nice, is to get, let's say, this 4 down here, you add together the two numbers above it. 1 plus 3 gives you 4. Okay? If I wanted to go and get this 3 over here, you would go and do 2 plus 1 gives you 3. This 4 is made up of 3 plus 1. Okay, so the coefficients, the numbers before every term in the binomial expansion come from this thing, Pascal's triangle. And we can finish it up by going at the top. Okay, 1 plus 1 gives you 2. On the top, 1 would go here. On the edges of the triangle, it's always going to be 1 down here, which is something to note as well. And you can keep going with this as much as you want to. The next row would be 1, 5, 10, 10, 5, 1, because you've got 1 plus 4 gives you 5. 4 plus 6 gives you 10. 6 plus 4 gives you 10, so on and so forth. So this thing is called Pascal's triangle, and it's really, really important, a really important and useful tool in looking at the binomial expansion. It gives you the coefficients, the numbers before each of your terms. Now we can look at the triangle. So if we look at a plus b squared, you can see, right, this 1, 2, 1 are the numbers 1, 2, and 1 here in the expansion. A plus b cubed, you can see you've got 1, 3, 3, 1, which are the coefficients you can see, 1, 3, 3, 1 over here. And a similar sort of thing with the one before. Now I'm just going to go and get rid of all this pen so it doesn't begin to look too messy. There we go. Now we can label Pascal's triangles in terms of rows. You call the first number, the 1, row 0, then row 1, row 2, row 3, so on and so forth. And this is really useful because the row numbers, they match the powers. Oh, sorry. For example, row 2 matches the power of the expansion, which is really important. Row 3 matches the power of the expansion. So it all links up nicely. And that would be row 4. Okay, and the 4 links up with the 4 over here. This is the first really key idea with the binomial expansion. You can get the numbers before each term by using Pascal's triangle. There's something also really important that we need to look at. If we look at every term, the powers always add to the power in the question. So in the first term here, you've just got a squared. Well, the 2 is the same thing as over here. If I look at plus 2ab, you can't see it, but a really means a to the power of 1, and b means b to the power of 1. They are there, you just don't write them because it's convention. And 1 plus 1 gives you the 2 over here. Then you've got the b squared. Well, square is a 2, so 2 is the 2 you've got over here. So the powers of every single term add to the power in the question. That must be the case. So if we look at a plus b cubed, well, you've got a to the 3. The 3 is 3 over here. You've then got 2 plus 1 gives you 3. You've got 1 plus 2 gives you 3. And 3 plus nothing gives you 3. That's really, really important. Okay. And we can also note from this as well, you can see here, if we look at the a term here, it begins with a to the power of 3. It then goes down by 1 every time. So it goes a to the 3, then a squared, then a 1, then effectively a 0, which is equal to 1. You just don't write it, of course. And the opposite thing with b, right? You begin with b to the 0, b to the 1, b to the 2, b to the 3. B increases in powers. Okay? And we can see the same thing with the last one, right? A plus B to the power 4. Again, your powers add up to the power in the question. You can see you've got 4 and nothing gives you 4. 3 plus 1 gives you 4. 2 plus 2 gives you 4. 1 plus 3 gives you 4. And 4 on the end. So the powers in every single term add to the power you can see over here, which is 4. And again, you can look at the powers like this. You can see, well, A begins at power 4. It then reduces by 1 every time. A to the 4, A to the 3, A to the 2, A to the 1, A to the nothing, which is just equal to 1. You just don't write it. And the opposite thing with B. It begins with B to the 0, B to the 1, B to the 2, B to the 3, B to the 4. So, looking at an introduction to the binomial expansion, we can see some really key things here. The coefficients, the numbers before every term, you can get from Pascal's triangle. Okay. We then saw also that the powers of each term add to the power in the question. We also saw that the powers for every term, for example A, if we look at this one, they reduce by 1 every time, 4, 3, 2, 1, 0, and the B powers increase by 1. B to 0, 1, 2, 3, 4. So before we end up this introduction video, if we just look at the last one, A plus B to the power 5, let's just see how we would expand this really quickly using what we've just learned. Okay, so first of all, because the power here is to the power of 5, using Pascal's triangle, we're going to need to use row 5 of the triangle to get the coefficients. So the coefficients are going to be 1, 5, 10, 10, 5, 1. That's the first thing. And let's just write those down. So it's going to be 1 plus 5 plus 10 plus 10 plus 5 plus 1. We then saw that, well, A will be given to the power of 5 to begin with. It's the biggest power. Like it was A to the 4 over here. So it would be 1A to the 5. And then B begins at the opposite, to the 0. B to the 0. Now, of course, B to the 0 is just equal to 1, so you wouldn't bother writing this. And 1A to the power 5, you can just write as A to the 5. Done. We then reduce the power of A by 1, so we go to A to the 4, and you increase the power of B by 1. So you would go to B to the 1, and B to the 1 you can just go and write as B. You then reduce the power of A again by 1, so A cubed, and you increase the power of B by 1, to B squared. You reduce the power of A again to A squared, and you increase the power of B by 1 to give you B cubed. Reduce A again to give you A to the 1, or just A, and increase B to B to the 4. Reduce A to the 0, which is just equal to 1. Increase B to the power of 5. And 1B to the 5 is the same thing as B to the power 5. So you've just expanded A plus B to the power 5 really quickly using sort of 3 key facts. Using Pascal's triangle to get the coefficients, okay, the numbers before every term. So you can't see it in this one, but you've got 1, 5, 10, 10, 5, 1. Then you can also see that the powers of every term, 5 gives you the 5, 4 and 1 gives you 5, 3 and 2 gives you 5, 2 and 3 gives you 5, 1 and 4 gives you 5, 5 over there. And you can also see that the powers of A reduce every time, 5, 4, 3, 2, 1, 0, and B increases every time. And that is an introduction to the binomial expansion, and you're now going to see how you can use it to expand brackets with bigger powers, okay? And then later on, how to find particular coefficients, but that's going a bit ahead. So in the next video, we'll look at this question. Thank you.